today we would be seeing like Hadoop 1.x architecture. Okay, let's understand how the architecture of Hadoop is. Okay, so whatever we saw yesterday, so about my distributed file storage or distributed file processing, so how that is being achieved in my Hadoop architecture, we'll try to see that today. So let's try to see today Hadoop architecture, and that is nothing but my 1.x architecture. Okay, so we'll try to understand slowly. It's a lengthy architecture. Hopefully it should be fit in an hour. So let's see. Now I'll try to draw a few diagrams and hopefully park your questions. Once I finish with the session, I'll try to take up the questions. It could be a scenario that your answers might get answered during the explanation. So let me start. So let's say I'm just drawing some few blocks, and why those blocks are being drawn, you'll come to know slowly. Okay, so I'm just drawing one block over here, and let's say one block over here, one block over here. So I'm trying to draw a 5-node cluster. Okay, so 5-node cluster means like we'll come to know slowly. So what are data nodes, what are name nodes, we'll try to understand that today. Okay, so let me just name this. So this is my name node. Okay, now what is name node, we'll see. And this is my data node, and what is data node, we'll see. So this is data node 1, this is data node 2, this is data node 3, and this is data node 4. Okay, so I've just drawn a 5-node cluster, and let's try to understand the Hadoop architecture, how my architecture will play a role in this. Okay, now in Hadoop 1.x, the block size of my file, okay, so whenever the file comes, okay, so the block size is, because the data needs to get replicated and distributed in different nodes. So for that, my block size is 64 MB, and this is configurable. As this is a default value, okay, as this is a default value, we can configure it, but by default in Hadoop 1.x it is 64 MB. Okay, the second thing is replication factor. So replication factor is 3. So what is replication factor means, like when the blocks will be written, the same blocks would be replicated at 3 different places. How? We'll try to understand in the architecture. Okay, now let's try to take an example that I am receiving a file of 100 MB. I am receiving a file of 100 MB. Okay, now with the block size of 64 MB, this file will be getting divided into 2 parts. Okay, I'm just taking a random example of 100 MB. It could be 1 GB, terabytes, and so on. So if you see, this file will be broken into 2 parts. Okay, and those 2 parts are nothing but my 64 MB, which is nothing but my default, which will be one part, and the second part would be, let me just take this, yeah, that is fine over here, and the second part would be the remaining. So the remaining part is nothing but my 36 MB. If it would have been 200 MB, okay, so how many chunks would have been there, how many blocks would have been there? Any idea? With the default configuration of 64 MB, if I would have receiving a file of 200 MB, then how many blocks would be there?
Four block.
4 blocks. Okay, so just to see the understanding. Okay, so now we are just taking an example of 100 MB. Okay, now let's move ahead. Now let's take, this is my client. Okay, what is client we'll try to understand later, but as of now just understand there is a client which is nothing but my edge node. You can say this is my client, or you can say this is my edge node. Okay, so we'll try to understand day before, day after tomorrow, what is client, what is edge node, number of nodes, number of clusters, and etc. Now let's take a scenario wherein this client, so this 100 MB file is coming. Okay, so at the client, okay, so whatever the request is being sent, so whatever the logic we are writing, or whatever the job we are executing, or whatever the computation we are writing, okay, so this is getting happened on my 100 MB file as of now. Okay, so this file I am trying to get. Okay, when I am trying to get this file, okay, what is happening in my client, I have just written some computation. So what will happen, this file will be sent to my name node. Where it will be sent, the request will be sent to my name node from my client node, client name, client. Okay, now when the request is sent from the client to the name node, what is the job of the name node? So the job of the name node is predominantly to do two things. Okay, and what are those two things? The first thing is to manage, the first thing is to cluster management, you can say. Okay, and the second thing is metadata management. Okay, so what are the two things which name node is responsible for? Name node is responsible to manage the cluster and to manage the metadata. Okay, so if you see, this entire thing is nothing but my cluster, and in this cluster I am having commodity of machines, and in these machines I have certain name nodes and I have certain data nodes. Okay, come back, no issues. Okay, so once the request is being sent, okay, once the request is sent from the client to the name node, so what is the job of the name node? The job of the name node is to do cluster management and to do the metadata management. Okay, let's see how it does the metadata management and the cluster management. So when the request is sent, so this 100 MB are being broken into two pieces. One is 64 MB and the other is 36 MB. Good. So what name node does is, with the help of metadata management, okay, so with the help of metadata management, what it does, it tries to take this 64 MB block. Okay, what it does, it tries to take the 64 MB block. So let me fill this with some color. Okay, so what it does, it takes this first 64 MB of block and it writes to a certain node, sorry, data node. Same way it just write to the before that. So the second block node, second block will come, so that is the remaining block, which is nothing but my 36. Okay, so that is nothing but my 36. Let me fill this with green color itself. Okay, and now let take me this. So what name node is doing, when the request is being received from the client, it is taking that information, okay, and as its work is to manage the metadata and manage the cluster, so name node, what name node does is, it maintains all the information of your data node. Okay, it maintains all the information of your client request. Okay, so which data node is having work, which data node is not having work, at which place my blocks are stored. Okay, so all these metadata information is being stored by whom? This person, name node. Why? Because its job is to manage the metadata. Okay, so once the request comes, these two blocks are getting written parallelly to different nodes. Okay, once the blocks are written parallelly, so if you see, this is 64 MB chunk and this is 36 MB chunk, these are written parallelly. Once they are written parallelly, they are replicated sequentially, and again the replication of both the blocks will happen sequentially, but as I am doing manually, I'll do one by one. So if you see, we have the replication factor as 3, so it will just go randomly to the available data node, and this replication is being done, and in the same manner we need to do, or the name node needs to do, the data node replication as well. So let's say this is coming and setting over here, and this is coming and setting over here. It could be a random thing. Okay, so now what has happened, my blocks are written parallel. Sorry, blocks are written parallel. And the second thing is, replication is done sequentially, or replication is done in sequential. Okay, so these two things have been performed. So blocks have been written parallelly, and my replication, which is nothing but my, as a factor 3, which is nothing but default and configurable, that has been done. So how that has been done? With the instructions of name node. Why? Because it manages the cluster and the metadata. Okay, so now this is being done. So when the request is being sent, so this bifurcation and segregation has been done. Now the computation needs to be get executed, right? So when the computation needs to be get executed, there is one more person. Who is that person? Job tracker and task tracker. Okay, so task tracker. So I'm just writing short form over here. So task tracker, and the same way task tracker. And let's come over here as well. It has one more task tracker. So name node knows which data node has the data, and and what job tracker has knows. Okay, so I am assigning my one task tracker in that particular data node to do the computation. So once this information is done, so what client node does is, what the client does is, it can now directly communicate to your data nodes, because it had one dependency, that on which data node I should work. Okay, so once the name node assigns the data node the blocks of piece to work, and the job tracker and task tracker, the client will be able to directly communicate with the respective data nodes. Okay, so once the computation is done, the result will be sent back to the client node. Before that, now once the data is written parallelly and replication is done sequentially, so these data node needs to represent, or needs to give a presentation, or give a presentation to the name node. Yes, that it means that the data node, whichever data node which I am trying to work on, so they needs to say we are available. Like in example of an employee and a team leader. So let's say there is one team leader. Under that team leader there are 4 employees working on it. Okay, so what these 4 employees will do whenever they are going to office in the morning, it could be a scenario, they either they would be filling the timesheet, or manually they would be representing to this team leader. So in the same way, here also what data node does is, data node sends a heartbeat. What it does? It sends a heartbeat to your name node after every 3 seconds. What it does? It sends a heartbeat after every 3 seconds, that yes, I am available. Okay, so what it does, it sends an heartbeat after every seconds to your name node. With this, your name node knows which data nodes are available and which data nodes are not available. Now, if the heartbeat is not sent from your respective data nodes to your name node, then there is a threshold. And what is that threshold? Heartbeat into 2. So there is a threshold. Let me write over here. So there is a threshold which is nothing but my heartbeat into 2, which is nothing but my 3 into 2, that is 6 seconds. If your name node does not receive a heartbeat from the respective name node within this threshold, what name node does is it makes your respective data node as dead. Okay, what it does, it makes your respective data node as dead, and whatever the computation which was, or whatever the amount of work the data node was having, that amount of work is being handled by another data node. Why? Because if you see, this block of piece is available over here and this block of piece is available over here. So hence your Hadoop cluster is reliable, it's available and it is fault tolerant. Why? Because even if your one of your data node goes down, still your work is not stopped or is not impacted. Reason? I do have the same piece of block replicated in my different data nodes. So what will happen once this data node goes down? Okay, so let's take an example. This data node is down as of now. So this, I'll just draw a diagram over here. So this is down. So when this is down, so the whatever the nearest location of that block is, so this will start taking the responsibility of doing the computation. But if you see this is down, then if you just take an example of this entire data node thing is, if you see, this is an example of my under replica. What is this an example? This is an example of my under replica. Why under replica? Because I have a replication factor as 3, and since my one of the data node is down, my blocks are not replicated with respect to my replication factor. Hence, it is named as under replica. Okay. So what the job is, what the job of name node is, to manage the cluster, to manage the metadata, what it will do, it will take the piece of work from this dead data node and it will try to allocate to the nearest. In the same way, so let me just copy this because it will be available with that. So let me just copy this and place this over here, and the same way let me copy this and place to the nearest one. Okay, now my replication factor is meeting 1, 2 and 3. So that is fine now. Okay, now let's take a second example. What if my, and again this, once this data node is down, okay, so now this data node is down, so what name node will do, for an amount of 10 minutes it will try to see, okay, so it will try to check whether this whether this data node is coming up or not. Okay, so if it is not coming, so whatever the replication will be done, that is fine. Now let's take a second scenario. After 10 minutes this data node comes up. Now let's take a realistic scenario. There is a team leader, and under that there are 3 employees. So let's say 8 hours, 8 hours, 8 hours amount of work is being allocated to 3 employees. But coming tomorrow, or let's say tomorrow, one person is not coming. So what will happen? So the 24 hours of work will be divided into 2. So they are getting overburdened. Okay. So now let's say on the third day, the third employee joins back. So what will happen? The 12 hour and 12 hours of work, whichever what was allocated, again that needs to get distributed in the 3. So the same scenario I'm trying to explain. So when this data node is up, okay, now let's say that this data node is up. Now when this data node is up, if you see, this is an example of, if you see this cluster, or if you just take an example of this data node, this example is nothing but an example of my over replica. What is this example? This is an example of over replica. Why over replica? Because I have a replication factor as 3, but my data is replicated more than that. And what is more than that? Because this data node was down, hence this person has also the same amount of work which was distributed and replicated to other worker nodes or to other data nodes. Hence it is an example of over replica. Okay, so what this name node does is, hence its job is to manage the cluster and manage the metadata. It asks this data node, hey data node, I have already assigned your work to some other data nodes. As of now, whatever work you have, please can you just erase that? Means ideally that would be done internally. So this amount of work, whatever it had, so that it tells name node tells data node, don't worry about your work now because I have already handled that. Okay, because that's the job of your name node, to manage the cluster and to manage the metadata. But if you see, I have 4 data nodes and one data node is sitting ideally, which means my data, which means my data distribution is not happening rightly. If I am having 5 employees under me, only 3 employees are working, 2 employees are not working and sitting ideally. It means that I'm not handling my resources properly. So this person's work is to do this job. So what it will do, as it will see, this data node is up, so it will try to manage the load balance, it will try to do the load balancing of your cluster. So it will just try to pick the work from some data node, okay, and it will try to assign back to your data node. Now with this, we have a load balancing in place, and now my data nodes are in sync with my replica factor, which is nothing but my 3. Okay, so name node is able to do that. Okay, so it manages a metadata cluster and etc, etc. Okay, so any questions till here? So this is just like one piece I have just explained. Then I'll go to the second piece of work, how the FS image, the edit image and the secondary image and the checkpointing and the failover mechanism comes into picture.
Yes, in the over replication,
Yes.
I mean, first it will erase all the data in the data node and then
No,
it
no, no.
will.
No, this data will be as is.
Okay.
If you just take, let's say you are the team leader and I am the employee, and let's say there is one more person, there are 2 person reporting to you. Okay, so now if you have assigned some work to me, okay, so let's say I'm doing that work and let's say some emergency came into picture and I left for the day, so the same amount of work will be available with me. Okay, and let's say tomorrow I am not coming, so what you will do, whatever the allocated work which you had allocated to me, you will assign to a different person. But if I try to report you to the third day and let's say you are coming late, or let's say you are available but into meeting, so I'm just trying to work. But what you will tell, I've already allocated this work to some other person, wait, I'll try to assign another work for you. So that work will be always available over here. So what name node will do, once this data node is up, it will tell that data node, I have already done the allocation, so wait, let me do the load balancing, or let me allocate the another work to you if I'm getting a different request from the client. So that's what name node will do. Got it?
Okay, which means it is just a look for the new work, so it doesn't bother about. I mean,
Yes,
uh,
it does not bother about the existing work. Okay, but it could be a scenario. See, internally how this blocks are they getting the same work, but ideally the same work is already available at different blocks, sorry, different data nodes, so the computation will not stop. Yes, but once the data node is up, whatever the work it had, that work, that data node will not be able to perform, because that had already been allocated to other data nodes.
okay. And one more question. So
Sure.
during, yeah, sorry, and during the job processing, suddenly it failed the data node.
Uh-huh.
So in that scenario, what will happen?
We'll try to see in the second phase.
Okay, yeah, thank you.
So just to answer that, let's say if this data
Saif,
node goes down, okay, even if
Saif,
this data
this
node goes
100
down,
MB file, like 64 MB and 36 MB, on what basis it will be divided?
so if you just see, I told there is a block size of 64 MB in Hadoop 1.x. There is a default block size which is 64 MB. So if you are
Okay,
receiving
that
100
is
MB
block
file,
size.
yeah, if you're
Okay.
receiving an 100 MB file, that will be broken into two pieces. If you receive 200 MB file, so that will be broken into 64, 64, 64, and the remaining whatever the third thing is, fourth thing is.
Oh, got it. Okay.
Okay. Okay, so let's make a move. If no questions, let's try to see the second phase, when the data comes or when the failover happens, and etc. etc. Okay.
Sorry, sir, I have one more
Sure,
question.
sure, sure.
When the data block is 64 MB,
Okay,
I mean, if let's take a example of 100 MB,
okay.
so one block is 64 MB, the remaining block is 36 MB. So, will the remaining the remaining amount of out of 64, 36 MB is allocated in one block. So the remaining data will be used by some other data. It's going to be an empty.
Uh, Means you mean to say I'm getting a file of 110 MB like that?
No, in the same 100 MB,
Okay,
64 MB is one block. The next block is 36 MB.
okay.
So, but the actual size of the block is 64 MB.
Actual
Correct.
size? No, no, no. Actual size, that is like, yeah, configurable, means this is the block size. Yeah, okay.
So, because my block size is 64, but I use only 36 MB.
No, 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 no. See, you are getting a file of 100 MB.
Yes.
Okay. So in this 100 MB, I cannot write this 100 MB file or 100 MB block into my different data nodes. So that needs to get broken into 64 MBs.
Yes, I understand that point. So, 100 MB is being splitted into two blocks. One
Right,
is 64 MB, another one is 36 MB.
right,
If the second block is 36 MB,
right,
but by configuration at the name node level, the block size is 64 MB.
right,
So if that is the case, I mean my hard disk has been split into 64 MB, 64 MB, something like that.
right,
So
right.
so if I place only 36 MB, so in that block, can I use the
Okay,
remaining
got
amount
it. Yes,
of
yes, yes. So if like I got it. So like there will be night. You're talking about the storage in terms of storage. So now let's say as I have a default block size of 64 MB, block is 64. Okay, so that blocks are getting playlist. But if you see in this and in my HDFS file system, this block is only taking a storage of my 36 MB, right?
Yes.
Okay, so if you see the remaining whatever the space is, so see, let's say, so this is the 100 MB, it takes 64 MB over here, and this is 36 MB till here. So the remaining part, whenever the next block will come, it will start using from here. So there will be no storage left as is because of my 64 MB distribution. So there will be nothing like that.
Okay, sure. Yeah, got it.
Any questions apart from that? Okay, no questions. So let's try to understand then the second phase. Okay, so I just erase this. So let me just copy this and bring it back. I just made a control Z out of it. Okay, now let's try to understand the second part. Okay, now when this client is sending, so how this name node is maintaining all the metadata information. Okay, because there are certain things which it needs to have, and with the help of certain things it tries to maintains the metadata. Okay, and what are those things? The two things which it tries to maintain is, the first thing is your FS image. Okay, and the second is your if you say, let me just take this over here. Okay, let me take this over. So for the first is your FS image. Let me just write this in a short form, FS image. Okay, and the second thing is your edit logs. Oh, let me just write. Okay, and the second thing is nothing but your edit logs. So there are two concepts, one is FS image and edit logs. Okay, now let's take a scenario when the client is sending a request at 12 o'clock. So the client is sending a request at 12 p.m. Okay, now when this client is sending me a request at 12 p.m., what will happen is, whatever the amount of work which this client is sending to my name node. Okay, so the job of name node is to manage the metadata cluster and the management of metadata. So at 12 p.m. when the request is sent by my client, so all the information will be stored, only the metadata, not the actual data. So all the metadata information means like which location I need to send the blocks, what is the location of that block, what is the which data node has having which block, and etc etc. So what name node will do, it will try to maintain all the information in the FS image and edit logs. Okay, at 12 p.m. and this and let's say this information is being written and data has been distributed and replications are being done and etc, heartbeats are being sent from my data node to the name node, everything is going smoothly, no issues. Okay, now let's take an example. At 1 o'clock there is one more request which is being sent from my client. Okay, so at 1 o'clock the again one request is being sent by the client. Okay, so again once the request is sent by my client, what it will do, the same information needs to be updated in the FS image or the edit logs. Okay, but before that what happens is, there is a person and that person is nothing but secondary name node. Okay, there is a person. So what this secondary name node does is, initially at 12 o'clock when the information or where the client has requested, so this FS image and edit logs were written. At the same point what happened is, this person also has an empty FS image. I'm talking about when, let's say, I have done my cluster installation the first time when my request is coming at 12 p.m. Okay, what are the two things happening? My fs image and my edit logs are getting written in my name node, and at the same time I'm having a empty fs image in my secondary name node. Now when the request is come at 1 p.m., which is nothing but my after 1 hour, okay, so before writing this or updating this fs image and edit logs, whatever information this edit logs is having, okay, whatever information that is being sent to the secondary name node, okay, so this fs image plus the new edit logs, okay, so the new edit logs, so let me write that, I'm not able to do that properly. So the edit logs which is being sent now from my name node, okay, so these two are combined. So now these two are combined, fs image and edit logs, these two are merged, okay, and the process of merging is called checkpointing. So what is this called? So the process of merging your fs image and edit logs in the secondary name node is called checkpointing, okay, and once this checkpointing is completed, okay, so there will be a new fs image. What will be there? It will be a new fs image, and this edit logs which it had, this will be get erased, okay. So I don't have a space over here, hence I have written outside, okay. So once the checkpointing is done, what you will have, you will have a new fs image, okay. So at 1 o'clock this fs image and this fs image are in sync. So what is the interval? So the interval is after every 1 hour or 1 million transactions. So this is the threshold. So whichever comes first, if 1 hour is lapsed or if 1 million transactions are being written in my fs image or edit logs, so what will happen, as soon as any of this is coming first, either my 1 hour is getting completed or 1 million transactions are getting completed, quickly this fs image, quickly my edit logs will go to my secondary name node, the fs image plus my edit logs, okay, what will happen in that merging of this fs image and edit logs will take place in my with a process called checkpointing, and a new fs image will be formed, okay. And once this is completed, so whatever information this edit log had, this will be erased, which means that at 1 o'clock this edit log will be empty, okay. Now at 1 o'clock again there is a request, so the same request is being appended to the fs image. So now fs image has data from 12 p.m. to 1 p.m. and from 1 p.m. onwards also, but this edit log has only information from 1 p.m. onwards, okay. So let's take 1 hour happens. Now let's take an example. 1 hour happens, so let me take one more. So now we are just trying to get information at 2 p.m. 2 p.m. okay. So if I'm getting an information a request from my client at 2 p.m., what will happen? Same thing will happen what we are trying to do, okay. So what thing will happen? So this edit image, so when the request is coming at 2 o'clock, this edit logs information will be sent to my secondary name node. So this fs image which had the earlier data plus the new edit logs which has received at 1 o'clock or 2 o'clock, the merging of these two will happen with a concept called checkpointing, and a new FS image will be ready, and this will be eradicated. Okay, so the same thing will happen at 2 p.m. So the FS image and the edit logs will be written, and again after every hour or 1 million transaction, my FS image plus my edit logs which are sent from the name node to my client secondary name node, the checkpointing will happen and the new FS switch will be informed. Now let's take a failure scenario. What happened is at 2:20 p.m. Okay, so what happened is at 2:20 p.m. when the FS image and the edit logs were written, so the process is happening instantaneously. Okay, but the sending of the edit logs is happen only after every hour. So at 2:20 p.m. what happened is my name node went down due to some reason. Okay, so this had the data, so this FS image had the data from 12 p.m. to 2:20 p.m. and this edit logs had only data of my 20 minutes. Okay, and due to some reason my name node went down. Okay, so my name node is not available. So let's take over here. So let's say my name node went down. So when your name node went down, so at that moment of time your cluster goes in a concept, and that concept is called safe mode. Okay, so when your cluster is down, it goes into the safe mode. Reason being is you are not able to access your metadata, so hence you are not able to access your data also. Okay, so if the new requests are coming, so name node does the metadata management, the load balancing of the blocks, the replication and so on. So hence the name node is down, so you are not able to access the cluster. So if you are not able to access the cluster, we need to bring this cluster up. So that is the part of the Hadoop admin people. So what they do is, so once this goes into the safe mode, what they do is, with the help of secondary name node, whatever the FS image it had, they try to do some mechanism and they try to take that FS image and they try to bring your name node up. Okay, now this FS image had the information from my 12 p.m. till my 2 o'clock. So the 20 minutes data this FS image did not had. Hence, why? Because the edit logs, the sending of edit logs from your name node to the secondary name node happens only after every 1 hour or 1 million transactions. And that did not happen. Hence my FS image at 2:20 p.m. was not updated. So when this name node failed and when the Hadoop admin people came into picture, they took the name my cluster went into the safe mode. So what they did is they took the FS image from the secondary name node, and whatever the whatever the work they have, the technical knowledge they have, they are trying to bring this cluster up. So at that moment of time, when the cluster is in safe mode, the client will not be able to process the data. Okay, but they will only be able to read the data. Okay, they will not be able to, so this computation, whatever it is happening in this data node, are halted. But client is only able to see the data. Means if you just give a request for seeing the data, you will be able to see. But if your request is of computation, like I have a command called sdfs dfs-cat, I'm able to read the data. Okay, that will be allowed. But your processing of, let's say I'm just trying to create sdfs dfs-mkdir, I'm trying to create a directory, that will not be happening. Why? Because the cluster is in your safe mode. And the Hadoop admin people, what they are trying to do is, they are trying to bring their name node up with the help of secondary name node and with the help of FS image. So in your Hadoop 1.x, we had one limitation, and that limitation was, the first limitation was failover limitation. Okay, which means that I have single point of failure. Okay, so the first limitation was single point of failure, which means that if my name node goes down, I am losing on some amount of data, which means that my 20 minutes amount of data I have lost. So it had single point of failure. So that was the first limitation. And the second limitation it had, so as my name node is going down, I cannot scale up my name node. So the second limitation was scalability. I cannot scale up if my this name node is burdened and I want to add few other name nodes. Okay, so there were two limitations in my Hadoop 1.x. The first one was single point of failure, and the second thing was scalability. So if my name node is going down, with the help of secondary name node, I am able to update my information, but in between, whatever the information or whatever the computation was happened, I'm losing that computation. So which is an example of single point of failure. And let's say now this name node is getting overburdened. Now let's take a scenario. Let's say some person, let's say Ritesh is a team leader and there are three people working under him. Now suddenly if he is asked to manage 15 resources, from 3 resources he is asked to manage 15 resources. At that moment of time, Ritesh as a team leader will be facing a challenge to maintain all the information. So hence the second challenge was my name node scalability, which means that if I'm getting more and more information, so if my burden is growing up or if my workload is going up, at that moment of time, I'm not able to scale up my name node. So the second limitation was scalability. Okay. So once this name node is up with the help of uh, FS image, again the same process will happen. So now the FS image will keep on writing and the edit logs will keep on writing. So this is your entire flow of Hadoop 1.x architecture. So it has block size, it has replication factor, it has data nodes, it has heartbeat, it has safe mode, it has a work of cluster management and metadata management, it has a secondary name node which does checkpointing, it has a under replica, it has a over replica, and job tracker and task tracker. So everything has a combination. So this is your 1.x architecture, wherein your name node makes a decision of managing the cluster and managing the metadata to your respective data nodes, replication, block size writing. Okay, so if is it under replica, if is it over replica, is my data node sending heartbeat? If not, I need to pick the work from another block size and I just need to wait if that data node is coming up within 10 minutes or not, and so on, and FS image and edit logs. So if so this is like 1.x architecture. So when initially 1.x came into picture, so it had couple of limitations and that limitations were overcome in 2.x architecture. So we'll see tomorrow 2.x architecture, but let's take questions on 1.x architecture.
Yes, I have a question. So in the one context architecture,
Yeah.
I mean, without having the secondary name node, I cannot create a cluster easily.
See, this secondary name node is just a backup name node. So it is coming up with your cluster. It is coming up with your architecture. So this is just there as a backup, but nowhere this name node becomes active. So it's just a backup wherein, let's say, if I'm starting my cluster or if I'm installing the cluster from today onwards, let's say 9 a.m. and let's say in evening at 6 p.m. it goes down. So whatever transactions, whatever information which had happened from 9 a.m. to 6 a.m., I need to have those information with me somewhere. For that purpose, we have secondary name node as a backup name node, and that's it.
Yes, if I understand that
Okay,
point.
sorry. Okay,
So my question is, let's say in the production under it is fine. And let's say I'm setting up my just a dev environment. It's
okay.
okay using the data also for a day.
Uh-huh.
So in that scenario, can I create a cluster without having the secondary name node?
Uh, on this question, I am not sure because I'm not from Hadoop admin background. But what I assume is, let me check on this, because what I am assuming is this is part of your cluster. Okay, so it's part of your architecture. Like whenever we are doing the installation, but you can take means it could be a scenario wherein if you don't want your name secondary name node in your dev environment, you can very well go with only in the installation of your name node and your data nodes. Okay, but you have to be ready, but you have to be ready in some, but if you have to be ready in a negative scenario. If your name node goes down, your entire data will be lost. You will not be
Yeah,
able
yeah,
to get the data whatever it is there.
yeah, yeah.
It is configurable, like it is up to us because we are doing the installation. So Hadoop admin people, let's say if they are designing an architecture, so in my dev environment they are not creating my secondary name node. Yes, that is possible. In UAT environment, even they are not creating that. Yes, that is possible. But in production, they are going with the architecture which is being levied by the different distribution like Cloudera, Hortonworks, and so on. So they are trying to manage the secondary name node there also. It is possible, but we
Okay.
have to be ready with a drawback. In let's say if that name node goes down, whatever the development which we did in one week or 2 week, the entire development will get evaporated or erased. So you will be at the zero level.
Yeah, yeah. Got it. And I
So
mean,
without secondary node, like the checkpoint is happening at the secondary name node only, no?
Yes, that's,
Checkpointing.
yeah. That's, we are taking a negative scenario wherein I don't want a secondary name node.
So in that case,
There will be no
wait,
checkpointing happening. There will be no FS imaging, but here only in your name node. So that's just a, means that's just a drawback. Actually, a pure drawback. So that's what he had a question. Ideally, it will not happen in the dev environment also and the UAT and as well as in production. So there will be always a secondary name node which will be a backup, because these machines are commodity of cluster which are like cheap machines. There could be scenarios like this could be attempted, or this could be happening a failure. So at that moment of time, we should have a backup. So there will be a secondary name node.
in development also, development and
Yes, yes. Ideally, everywhere, at every place, in my development, in my UAT, and in my prod, all three phases, we have the secondary name node also.
but in the development it's cost effective, not necessarily
See,
like
that's what it depends from the architecture to architecture. If I am
okay
being the
because
if I am trying to architect my things and to be at a safer side, I will always go with my secondary name node even in my dev environment. So that is purely decided by the architecture and the Hadoop admin people. So that is not our stake. As a developer, we are not bothered about it. That is the architecture, what they are trying to build. So in dev environment, if they have decided for cost effective, I do not need to have my secondary name node, no issues. But they need to be ready for the failures also.
and here a client edge node means like is it the developer or any SFTP or any automatic
Don't worry about this. So as of now, as a layman language, just remember this client node, which means that from where your jobs are getting executed. Just remember that, because day after tomorrow I'll explain you what is client node, what is cluster, and when you execute your job, how your job gets executed. As of now, in a layman's language, just remember your jobs are getting executed from this place or triggering from this place. Just remember this as of now.
So these are all at the time of installation, or like admin will do. These are all
Yes,
activities.
these all activities of our Hadoop admin people. Okay, so this is not about my work. Okay, so this is only about Hadoop
Time of
admin work.
initially
Huh?
project starting time, they will decide like
Yes,
they
yes.
will get.
Right,
Okay,
right,
got
right.
it.
See, see, as a developer, so when the initial requirement phase, gathering phase goes on, so when we try to take the technical requirements, at the same time, the Hadoop admin people will be also working, right? Because as a technical architect, he's as a means as a solution architect, he will be designing the architecture, and that architecture will be getting implemented for that project. And to get implemented project and the developer to work on that project, we need to have machines to work on, right? So at that moment of time, simultaneously, when we are working on understanding the code, what code we need to write, or what logic we need to write, or what how will be the architecture, at the same time the Hadoop admin people, what they will be doing, they will be creating the cluster and making that ready for us, so that once that cluster is ready, we'll be able to work on that clusters. So it's Hadoop admin people's job. We don't need to worry.
Yes, sir. I have one more question.
Sure.
So, in the name node, FS image is nothing but a metadata.
Yes.
Okay, but in the secondary name node, FS image is nothing but a metadata plus edit logs. Correct?
Yes, metadata, fs image plus edit logs. But when that happens, after every 1 hour, when the name node sends the edit logs to the secondary name node, at that moment of time, the older fs image plus the new edit logs, what will happen, the checkpointing will happen, and the new fs image will happen. Yes, so the fs image will be a combination or a merging of your existing fs image plus new edit logs which was sent by your name node, right?
Okay. Uh, yeah. So since we have two different name nodes, one is primary and one is secondary, so why they had to manually bring these FIS images to the primary when the primary is failure? Why they can't put it in a high availability?
That's where the architecture came into picture. So it was initially introduced as a Hadoop 1.x, so they did not thought of this. Okay, now let's take a realistic example. So how we go in the development environment, we try to write the code for us. Okay, and once the code is being tested, we push it into production. Okay, now what happens is there is certain change request is coming or some enhancement request coming after what you have pushed the code into production. You didn't know this earlier, right? Because the client has sent that information afterwards. So in the same way, when Hadoop 1.x was into the market and when people started using this, they came up with this drawbacks and limitations. And hence
Okay.
this availability which you are talking about, which is nothing but failure, a failure thing, so that was taken care in the next release. So like how we do, once we push the code into the production, and if there are some performance optimization request or some change request, we try to take that into a second release. So the same thing happened. So whatever the failure mechanism and the scalability was taken care in the 2.x architecture, and which is being running now successfully in everywhere. So that's we'll be seeing tomorrow.
Okay, got it. And I mean, just I have previously asked a question that if the data node is failed during the middle of the execution,
Right.
so if somebody doesn't have any question, can you answer
No,
that
no, no, no. You
question?
go ahead. No issues. It's not means you, let's finish with yours and everyone will ask. No issues. Please go ahead.
Yeah, okay. Yeah. I mean, if the data node is failed, because my job is running, assume that my data is being split into three different data nodes.
Right.
And in one of the data node during about the job is about to complete, and then suddenly my data node failed. In that scenario, what will happen?
So are you talking about the name node failure or only data node failure? Again, the
Only data,
only
only
data
data
node. Yes, yes. So if your name, let's say your 95% job is completed and suddenly your data node goes down. So whatever the computation that this data node has done, so that will be wasted. So what name node has to do, the same computation will have to be performed by this data node or by this data node.
Which means if it is failed, so it is going to create the same job in other data nodes.
Right. Why? Because it already has the data, it already has the block of work available over at a different places. It is not a complete failure. It is just a
Mhm.
failure for that moment of time. But another person will come into picture immediately, and 3 seconds, and sorry, 6 seconds, it's like just a minimal time. Immediately what it will do, the name node will do, it will just try to inform the second or third data node, quickly pick up the work and do the computation and send the result to the client.
Okay, okay, got it.